good. Thank you. Yeah, I'm Laurel. I'm founder of Biohacking Safari, which is integrating biohacking facts for this conference. I work with Kitty, which she's not here. She's staying in France, and so Elena is going to replace. She's going to mediate the discussion later. I'm going to present to you Pablo, which is Spanish. He's come from Bilbao. He's part of the public lab community, which is a DIY citizen science structure, and they make kits for citizen science. I have more details on him. He's also, he makes research on waste, and he's part of some waste community, so they collect waste and then, not the waste community, but they collect waste and then they try to reuse it and try to make the whole network related to waste. So yeah, it's going to present his thing, and maybe I can present you later.
Yeah, or now if you want to.
Alright, yeah, alright. And Philip is just right here, is going to speak with Pablo. So he's blurring the lines between between computation and synthetic biology. He's a founder of Bento Lab, which is this kind of equipment, which is a synthetic biologic tool that you can take with you. It's a mobile laboratory, basically. He will talk about this, and he's also he have work in Japan in the media, biomedia art, and that's I need to be precise on this one. Otherwise, it hits later, so we're in the same house. So thank you, and is it?
Well, yeah, I'm going to start without the. I'm rebooting because it was like, you know.
Okay.
So thank you for coming. I will repeat my name again. I'm Pablo Rey. I work in different networks or associations or different spaces. And one of the places I collaborate is Public Lab. Public Lab is like it's an organization based in the US, but there's also a network of people involved in different development of software and hardware and community involvement around citizen science. So what I want to give you today is a glance of the things we do in Public Lab. I am based in Spain, where I am like a Public Lab organizer, which means like a kind of ambassador. I collaborate in the community. I organize workshops, especially about aerial mapping, so that means balloon mapping, putting a camera hanging from a balloon or from a kite and making photos. And later on in the next session, I will share with you how to, like the basics of how to put a camera on a balloon. Sorry for the inconvenience. Yeah, so this is like how this session is about tools for open science, and so I want just to give you some ideas of things we've learned in the community in Public Lab. So what we do is about do-it-yourself and critical making, because we want to have a broad approach of how we define science and how we define a problem. We want to make a kind of citizen science where citizens and people are involved in the problem definition, in taking the data, analyzing them, and into action. So that's and making the tools and modifying the tools. So for us, it's important that people are involved in all parts of the process, which involve critical making, which means that people have to understand how those tools are created and how they can intervene the power structures around science or policy creating and all that. So in public lab, it's all or almost all about access. It's not just creating the tools. There are out there lots of free software and free hardware projects that are great, and these are also public lab projects are also as good. But we take a lot of effort in building this community around these tools. So it's about building the community, creating the tools, and creating the channels of communication between the different places. There are different. We organize ourselves mainly through the websites and through mailing lists, like in many other projects, and there are like thematical mailing lists, and also from chapters or local chapters, what we call. For example, there's one in Massachusetts, one in the south of the US, one in Spain, like different chapters where we share ideas and tools and development. So we're going to be more centered today talking about balloon mapping, but there are a bunch of other tools that are being developed, like for example thermal photography, spectrometry. The idea is to make affordable tools with the materials and sources that we have near us, and to make cheap and affordable for everyone. So for example, one that I like is this spectrometer. It's just inside there is just a webcam, and to make the diffraction of the light, we use a DVD, because it's like it's set like to diffract light in the same way as a prism. So this is like I think it's like you can do it for $40 or 50, depends on the quality of the webcam. You just plug it in your computer and you just use it online, and you can get the spectrometer of different materials. So if citizen scientists, I made this big space for science where citizen scientists at the right, and inside citizen science we have like from the volunteer distributed computing, this project where you help to code something, and the other side like the grassroots or the do-yourself science. So we want to show that public lab is involved in all the steps from citizen science. There are some great projects, for example, those that are familiar with, like Sonyverse or Boeing, that are classificating as a people, and users are helping to classify one piece of all this data, and then other people are using those data. We want to say that we are like in all the different steps. So we want to push citizen science to not only working with the people from the university or postgraduate or PhD from high school, but to make those limits broader, and in order to work with children or with other communities that are not so academic or whatever, and also to bring them into action. So not only collect those data and analyze, but also to do something. We are especially concerned with environmental issues, and that's where we're in the space where we are working. So balloon mapping is about it's a technique we started like. So we didn't start this. Many people were doing this before, of course. Balloon mapping has a history more than 100 years of making photos from balloons. But we are trying to do this in an affordable way. So this is a camera, basically, hanging from a weather balloon. And we just put a bottle, protection. That's why we have some bottles here, to make it, if it falls or whatever, it doesn't break. So this is like a normal setting how it would look. A normal compact camera, we use like a $60 camera or something. Making photos in a continuous mode, and with the screen we can go as up as 300 meters, or depending on the regulation of the place where we are making the photos. If you don't have a weather balloon, you can go to one of these shops, party shops, and buy small balloons or really small balloons and put it all of them together. This is some photos we were making in Madrid about some ruins in the outskirts of Madrid. And we produce photos like this. No? You just create a new satellite image up to date and that you own and you can share with others. So it's especially important for environmental issues where you can track a space and you don't need like to be on an airplane or a helicopter or whatever. You can also even make your own balloon, because you need a really big balloon. This is just with hot air. You will need a much bigger balloon to lift like a camera, a 100-gram camera. But so there are like other people researching on this in this way, no? Just with black plastic to make a big camera. Of course, helium is the more expensive part in all this process. You have to rent the helium, or you have to buy. You can spend like €100. It depends on the quantity you need. But of course, we can use kites. Kites, you can fly a kite when there's no wind and you have a space. Maybe in the city center, it's difficult to fly a kite, but on the countryside or wherever you can fly kites, and it works as well as flying balloons. And you don't need you can also make your own kite. There's lots of groups making their own kites. And I just wanted to show you that how the process is. You just have the kite or the balloon or whatever else, and you just have to hang from the string the camera. And there's like the operator is the person pulling from the string, and it's just you need to know a little bit how to fly a kite, which is not that difficult stuff. And then they have prepared the camera. There, they're going to make the first photo, and they have like a rubber band pressing the shutter, so the camera is making photos every 1 or 2 seconds. And they are making like this in the string, just not to make a note, and so it doesn't hurt the string. And so the camera is already making photos all the time, and you just leave a space between the kite and the camera, like 10 meters or something. So in case the kite falls, you have like a little bit more of time to get it. So she's making the first photo, and that's it. So a similar process would be made with the balloon, but without the wind, so it's like even easier. So that will go up as the string you have. So where we have been using this tool for area photography, for example, we in Peru, like helping this Cantagallo settlement, like kind of a slum area, to make photos of their own place. We were making a workshop with children to make a map of their place to help in their negotiations with the city hall. That was like one of the first projects that regarding balloon mapping and grassroots. It was called by the time grassroots mapping. It was Jeff Warren, one of the founders of Public Lab. Another big moment for Public Lab was when the Gulf spilled in the Gulf of Mexico, where a lot of the BP platform exploded and a lot of oil was coming to the coast. So different people from the US gathered in New Orleans to make workshops to teach people how to make this kind of photographs from kites and boats. And this is the barrier to prevent the oil from coming to the coast, and they could photograph some places where it was broken, and they could photograph the coast before the oil was coming, because they could not trust the data from the government or from BP. And so they make a huge number of photos about the coast and how things were before and after the Gulf spill. So it's been used like for wetlands, for waterways, to monitor how industrial areas are developing. I will pass it briefly because it started a little bit late, so these are some photos, like for example, to monitor demonstrations and to promote what people are doing in Chile. Students demonstration, they were streaming one demonstration from the up in the air. But the video is not that good because it's moving like a lot, but it kind of worked. For example, in the Czech Republic, they were photographing places where they were cutting logging in the forest. And in Spain, we're doing also waterland monitoring near Valencia. These are the photos. Sometimes the camera is up there with the wind. You don't always get straight photos, like ortho photos. Sometimes you get like this perspective, like this, and then there are also tools sometimes that this kind of error works. And even to pass over these projects. For example, in Barcelona, we were making a project about in the public space how the squares in Barcelona were being used by the public, and we're making a workshop with the neighbors to talk about these squares. How we made this photograph. This is in El Raval, in the neighborhood, and with the help of other people in Dailly, with Juan Pablo Torrente, we made this 3D model, because when you have a bunch of photos from a 3D object, you can rebuild like a cloud of 3D points, and then you can make a 3D object out of just from the 2D photos. I don't know if, well, that's one of the uses we found, that you can like reconstruct 3D buildings or 3D environments just with single photos, because the camera is out there making photos from every place, and then you can rebuild the space with 3D. So once you have all the photos, you have like maybe 100 or 1,000 photos, because the camera is making one photo every 2 seconds. So imagine how many photos you have. Many similar photos, some of them are blurred, some of them are in the wrong angle. So you just want to select the good photos, and you have to stitch them on the map. We've created this tool, is a map knitter, which is like literally like knitting like making a puzzle with all these images. As they are not orthophotos, you have to distort them. You see them like they are a bit distorted, because if you take a photo from an angle, you need to distort it to rectify the position and everything. And so with this tool, you are able to reconstruct and build a map. And that's Map Knitter. It's another free software that we host online, so you don't have to install it in your computer. You can use it online and build like things like this. Like this is a landfill in Boston that we took like 7 years ago. So Public Lab is about making the tools available, but also promoting like to make a public archive of those data or of those images. And here in publiclab.org, you can see all the different maps that people have been created. In Map Knitter, you see like the maps on the making, and here you see like the final result of those maps. I'm going to jump this part. So I want to close with some of the things we've learned working with these tools and with the community. So we like to say we want to engage with researchers, not with subjects or users. So people who are working with our tools or with us, we want to convert ourselves into researchers, not just helping someone else to get the data, but just all together define what we do and to collect data and analyze them. Sometimes it's about really simple hacking things, like for example, how to press the bottom of a camera to make it work. So it's just, as you see, a rubber band with I used to like to put here a small stone or a piece of paper or whatever, but there are multiple solutions there. So when we make a workshop, people say, but this could be done better. We say, yes, sure, do it. For example, instead of doing this, you can install the Canon Hack Development Kit in your SD card for the camera and make photos every 2 seconds, or you can make it like better or in more hacky way, but this is as good and it works. We also, people say, why you are not using drones? So we say, well, we like to be attached to a string to our camera to show that we are the ones making the photos, so you can follow who is making the photos. And so we want to create these collaborative flows where people engage in building the tools, using them, and publishing the data, as with the spectrometer. With the spectrometer and the spectral workbench, we have like every spectra that people have been doing, from all kinds of contaminants, soil, water, or whatever, and you can compare your data with others. So that we encourage people to share the data. And we also work with free licenses for software, hardware, and content, like the shared Creative Commons and GNU. And we love to see how different tools are being changed and developed in different ways in different places. And so the last three big questions, thinking about this kind of citizen science, is: if you aspire to democratize science, how do you balance expertise and democracy in your practices, in your work? What are the processes to which technical practices can be changed, and how can you work extend to include government's acknowledgement of community and grassroots concerns in a way that changes policy, regulations, and scientific practices? So that's the big, like, three things we want to think when we talk about citizen science. And regarding access, we think everything is not just building a tool, but it's about access. How we design about inclusion, how we consider that everyone has an expertise and something to teach, and to address the full cycle of data, so from collection to action from the data, and to make affordable tools. So that's about it. Thank you.
Maybe we continue with you, and then we have some questions if you have any.
Test 1, 2, 3. Are we good?
Okay.
Oh, terrific.
1, 2.
Yeah, so as you can see, I'm Philip. So I'm going to talk very briefly just a little bit about the tools and infrastructure that we might want to create to make to bring biotech into citizen science and to create maybe something like bioliteracy, as in more intuition and more understanding of biological phenomena and biological terms. For me, this whole thing started a number of years ago when I saw this website. This is the iGEM Registry of Biological Parts. This was also on the chart from Pablo, I saw.
Yeah.
So this is basically a catalog of genetic parts. So these are DNA parts. So you might look for something like red firefly luciferase, which is the thing that makes a firefly glow. Because maybe you want to use that in a project, just like you use an electronic component, like a transistor, in a project, or an Arduino component. And you might take this and put it into bacteria. It's a bit more complicated, but but basically you may take this part, put it in bacteria, and you make a bacteria lava lamp. And I mean, this video is awesome, but it's a big slideshow. So for us, so I was part of the London University team that was part of this iGEM community. So at that time, and still, iGEM is predominantly a academic community. So different, mostly student teams, I think now 300 around the world, contribute parts into this catalog and use them for their projects once a year. And I was very keen to start a collaboration with a local hackspace, because there was a group called the London Biohackers, and I thought, okay, great, we can get all these extra hands to do more pipetting and create more parts. But actually, it turned out that they were mostly interested in biohacking, but didn't really have the tools or the knowledge to make that happen. And so it turned out that we kind of started a collaboration to build a biobrick. This is what these parts are called in the registry, that they could build by themselves. So this was exactly as you said. Don't just maybe crowdsource your science, but actually make or engage people as scientists themselves. So we said, let's try to kind of train you up like we train undergraduates, and you can choose whatever biobrick you want to make, and then we'll put it into the registry for you. This is what we did with them. This was back then the space in London where they did their work, basically like a tiny cupboard. The BBC called it biohacking closet or something like that. But we really did all the training and safety stuff, and really explored also legally what you can do within those spaces and what you have to do in licensed university or industry spaces. So we did, we made, actually I say we, but the biohacker community chose the paths they wanted to make, we designed some workshops to do the basic techniques. And then we also invited them, so we made some incubators to grow cells. So we did all this kind of hacky hardware stuff. And then we also invited them into a university lab to do the final steps, which we had to do then. Now actually, this was a few years ago, now they actually have their own license space to do this kind of work in their own premises. So they've kind of progressed from that point in the community. And actually, Ilya from the Biohack Space will talk later today, so if you're really interested in what they're doing now. We also then, this is quite important to us, is to not just, obviously someone who's already self-identifies as a biohacker is already quite a biased, selective person. I mean, it's not someone you just find on the street and say, you're a biohacker. This is already someone who goes to a hack space who says, I want to do this. It's quite a special kind of person. So we also, it was important to us to engage this topic with a wider audience, so we brought it into a museum and kind of curated an exhibition around those kind of projects and actually kind of showed the DNA that the hackers made. And yeah, and also actually right now the university and the biohack space is publishing a paper on the project I did 3 years after it was done. It's kind of now in the peer review process, which is also nice. Like it can actually then go into kind of legitimate journal science, whatever that is. So since then I've been really interested in this community, and there have been a lot of meetups in Europe, DIY Bio, EU as kind of a community, but it's a very loose community. And what I noticed was just that there are a few things that we always ended up talking about. Every time we talked about things like starter kits and common materials and accessible technologies, and that those things would be really interested to really get started, and that really every year we met, we were kind of talking about the same things. And so a friend of mine, Bethan, and I started a company called Bento Lab, because we thought, well, let's try to solve some of these challenges and start maybe with hardware. And really our very basic pitch was, well, a computer looks like this right now. Sorry, it looked like this in the 60s, and now everyone has a computer. So our kind of naive pitch was, and this is a very false analogy, but was that right now a lab looks like this, a bit like a computer in the 60s. It's a room with lots of things and people work in it. So we thought maybe labs of the future and labs that citizen scientists can use can be more like laptop computers these days. So actually before you, so the first thing we did was we went to Maker Faire Rome, which was just around that time, and we just had basically an empty box that we asked people to imagine what this might be like, and what they would do with it if this was a biotech lab. So we had basically a box with with some things drawn onto it, and had a little PCR-ish block on there. But it was basically just a make-believe thing where we wanted to have conversations with people. And based on that, then we started designing different products, like the one that Dailly is now showing. So that's our current Bento Lab. So we have currently about 20 of them that we're testing, and we're starting. Thank you. We'll turn it on later, but basically we're testing them right now on different projects and working with a manufacturing partner to bring them into education and things like that. But basically it's like the basic molecular biology tools that you'd want. So this has a PCR machine, which is a fancy word for basically a DNA copying machine. So it uses enzymes, controls enzymes with heat to be able to copy DNA. Has an area for visualizing DNA, so you get those kind of CSI fingerprint images of DNA barcodes. And this has a centrifuge, which I guess is kind of the basic, easiest tool. So things you can do, just one very quick example is, if you're worried about your burger, as Europeans might have been a few years ago, you can take a sample and look for markers to tell whether it's horse meat or beef or both or something else entirely. Or whether your sushi is genuine. So what we're interested in, and this is a long way off, but you know, there are these kind of public technologies like Arduino in electronics that kind of really has kind of helped invigorate a maker and citizen science community around that topic. And we want to culturally bring that into biology. So right now we have this, and hopefully very soon with a manufacturing partner to make them a bit more widely available. But really, that was only the beginning, and it's not really the most important thing. You kind of need this, but what you really want is to go forwards. Yes, what you really want is okay. So what you really want is a fast computer, and there you go. So what you really want is for that to be filled in and to have the culture and community around this. So you really need infrastructure for kind of safe usage of the enzymes and the biomaterials, the wetware. So we call ourselves a hardware, software, and wetware company because we need the software and to engage community into, so you know what you have to do, and actually you find some projects that you might want to start with. So that's what we're really working on. And these are some of the projects that beta testers are doing right now with this tool. So we have a project in Geneva that basically analyzes different strains of yeast and what beer they produce and how that taste is linked to the DNA. Some kind of science outreach projects in rainforest in New Zealand, and then also more kind of maybe things that are a bit strange at first sight, things like art and design workshops where media people and art people use engage with the techniques of biology and community labs. So yeah, we want to kind of become something like a Raspberry Pi for biotech, not just in the sense of the hardware, but in the sense of the applications and the culture around it. So maybe that's all I'm going to say, and hope that you have some interesting questions for us. Thank you.
Yes, so thank you, Philip and Pablo, for the great talks. Now, first, do you have any questions from the audience? Something that you would like to know?
Do you want to sit down?
Yeah. No questions? Okay, so I have a question. How much does it cost the dental lab?
Yeah, I mean, right now we're not selling.
Okay.
So we actually charge beta testing projects about £450 because we don't have much funding.
Okay.
So we have to kind of be able to at least pay for some of the stuff.
So is that an obstacle? That's like a question for you. Like, what is the main obstacle to in these activities for democratizing science and involving people in
just
research?
to follow up on that, right now we're partnering with a manufacturing company because what we want to be able to is really transform where those technologies can be used. So we're talking about schools, we're talking about really more like hands-on undergrad education, as well as the DIY biocitizen community. And so we kind of have to go now through the process where we can manufacture them at a good cost, and also with like CE mark and all the things you need for regulated, safe electronic devices. So we have to kind of progress a bit beyond the Kickstarter phase where you might just you don't look too closely at the regulations.
Yeah.
So yeah, for us, one of the things we're definitely looking into at the moment is how we fund that in a way that we want to be funded, because it's not something that like venture capital is really interested in, and we're also not really interested in that.
Yeah.
Yeah.
So I think in your case you're really like using bringing biotech tools to the public, and in your case it's kind of like the way around. It's interesting. It's like people create their own tools for their own purposes. So I wonder like who is involved in that exactly, like in the different cases that you show, like because you work with local communities, right? How people perceive that, like who really tries to engage in it, and how locally how does it work?
Yeah, well, the development of the tools is mainly like empowered or produced by the people in the public lab staff and people promoting it. Like this balloon mapping kit that we are also like, we sell, but we also propose people to do them themselves because it's just simple pieces that we put together in a box that people can do it themselves. And but some others development are between the people like in the organization and the community. That's how it develops. It's not like we don't expect to go to a neighborhood to make a workshop and people develop from scratch new tools. That's, I don't know if that answers.
It's more. There's a question.
Yeah, just to follow up on that thing with the schools. How have you experienced the interest among teachers in schools and so forth to engage in this kind of activities? And in general, I mean.
So for us, we definitely look very closely at the different curriculum, because even if teachers, I mean, at least in the UK where we're based, even if teachers are interested, really, if you want to sell something to a school, it has to be something that the teacher can justify doing. So it has to be something that's related to the curriculum. But thankfully for us, biotech is getting a bit more traction in the curriculum, so some of these things are now there and they're looking for tools that are easy to use and engage with. But to be quite honest, classrooms were not the first people we thought of. It was really more like like one or two people doing research, but doing it maybe out in an environment that's not a professional lab.
Yeah, we work with teenagers and kids, but not in the class environment. Or outside that. I want to add one thing. I mean, regarding the Kickstarter phase, and we've gone through that for different projects, and then now we are able to, through crowdfunding, we started selling some of the products, and then we just sell them like independently.
How do you manufacture your kits?
We have like a. It's more sometimes in manufacturing. Sometimes we just, for example, for the spectrometer, it's more than manufacturing. You just receive the material and you build it yourself. Yeah. But this is like usually common material. You just get the webcam that you can buy. But if you get this webcam, it's like the right size that fits this other component that is just for cables. So it's not. We don't. For example, for the near infrared camera, we sell this filter, this blue filter. So you have to remove your UV filter in your camera and put this one. But of course you can buy this filter by yourself in our place. And then we managed to, for example, to modify one camera from Mobius Cam. It's like the cheap version of the GoPro cams. And then we were able to talk to the manufacturer and see if he could remove this UV filter and add our filter. So you get a near infrared camera. So the process is very different. Sometimes you just have to put the weather balloon and the spring together in a box and
so it's very kind of, it really leverages the existing supply chain, and you kind of can reconfigure some things or put things into new combinations.
Yeah.
So that's obviously
but I mean it's not. I think it's not as complicated as to your lab. Usually our tools you can make them by yourself. Maybe it's easier if you buy them all in a box, but you can do it. I don't think you can buy that.
I mean, I think for us it was really this. I mean, there is a lot of even when we started, there was a long history of like open source PCR machines, and I mean all these things you can build them yourself. So when we went to these meetups, we didn't think, oh, okay, that people cannot make their own PCR machine. We just realized that that takes a lot of skill and a lot of knowledge, and we kind of thought that there must be lots of people who might want to do biology who don't want to learn how to use Arduino and solder and do all those things before to build their own lab stuff. Maybe that's almost a different activity, and it's great when people make their own hacked lab equipment. But that's like a totally different activity to doing biology. So maybe some people love doing both, but we wanted to empower those that actually had an interest in doing biology and for them to get started. So it's kind of a different target audience, as we saw.
So how does the audience perceive those tools? Like, do they really, as a citizen, do they really understand what they can do with it? How do you show them? Like, how do you, you can do research, you can do science, but do they really see the direct benefits?
I mean, I think there are different ways people have to engage with tools. Sometimes people have bought the kit and they are not using it or they don't see a use of it. for it.
Yeah.
Or sometimes people have a need and they approach us, and then we can lend a tool, and then we have something so that is normally speaking in libraries, so you can have them for a while. But it's just, I mean, it's really broad to say how to follow.
One last question from the audience. Yeah.
We are out of time.
Okay. So thank you very much.